Section 4.5 is about the graphs of sine and cosine. In this video, I want to work through the graph of y equals sine of x. And I know you've seen that before, but I'm going to present it as if we're figuring it out for the first time. Because if it's something that you understand, great. If it's something that you just have memorized, I'm hoping that you'll leave this video understanding a little bit more where it came from. Okay. So I've got up here on the board, here's my unit circle, and I very carefully labeled the axes here, capital X and capital Y. That's because I'm using little x for the angle. So little x is very different here from capital X. And you might say, why are you doing that? You mean person, you're trying to confuse us. No, I'm trying to help you avoid confusion because it's very, very common to use x as the input for a trig function. And we need to distinguish that from capital X, which corresponds to, of course, if this is the unit circle and I've got a point capital X, capital Y, the capital X value is cosine of my angle, and the capital Y value is sine of my angle. Okay. So the angle x, very different from capital X, the coordinate of the point that I have on this plane. Okay. So on the unit circle, I've just sort of marked off the points where our quadrantal angles are going to intersect the unit circle, and I've labeled them for the quadrantal angles that correspond to just one revolution from 0 to 2 pi. So this would be 0, pi over 2, pi, 3 pi over 2, and then 2 pi is coterminal with 0. Of course, there are lots and lots of other angles that are coterminal with those quadrantal angles, but I'm going to just work with that one revolution from 0 to 2 pi at least initially. Okay. Now over here is where I'm going to be graphing y equals sine x. So let's see if we can understand how this graph is going to relate to that graph. So here, the horizontal axis is the little x-axis. This is where I'm putting my angle. So I'm thinking of little x as being my angle, and little y is going to be the trig ratio that I get for that angle. That's pretty much how any trig function is going to work. If y is a trig function of x, x, my input, is the angle, y, the output, is a trig ratio. Now, in a lot of applications, we're going to think of our input not so much geometrically, not so much as being an angle. We might see in applications, we start to think of that as time. But from the definition was a geometric one where we thought of that input as an angle. Okay, now over here, I'm representing little x, my angle, rotationally. So as x increases, we're rotating counterclockwise. On this graph, I'm representing little x, my angle, as a point on this horizontal axis. So as x, my angle, increases, I'm moving to the right. So they're linked. If I'm at 0 over here, I'm still on the positive x-axis because I haven't rotated away from it. I would be at 0 on the x-axis here. As my angle increases, over here on the left, I'm going to be rotating. Over here on the right, I'm going to be moving to the right. Okay. So the angle increasing is just represented differently in these two pictures. And I've, of course, now erased my angle. Okay. So I'm going to mark off the quadrantal angles here. So here would be 0, then pi over 2, pi, 3 pi over 2, 2 pi. So 0, pi over 2 pi, 3 pi over 2, and 2 pi, those are the quadrantal angles I'll hit. Notice there are 5 of them in one revolution around the unit circle. Okay, so if I'm graphing y equals sine x, my input is going to be the angle. So going from 0 to 2 pi is going to correspond to over here, rotating once around the unit circle. The trig ratio that I'm spitting out is the sine value. And that, of course, is the capital Y value. So for this particular trig function, little y and big Y are the same. That won't always be true. If I were graphing y equals cosine of x, little y would be the capital X value. Okay, so I'm going to just mark off the points for my quadrantal angle. So it's almost like we're getting in a car, we're driving around the unit circle, And we're looking at these signposts along the way that are telling us what our location is, and we're just reading off the y values, the capital Y values. Okay. So when my angle little x is 0, I can see that we're intersecting the unit circle at this point that has a capital Y value of 0. So the sine function goes through the origin. When my angle is pi over 2, we've rotated up to here. We're at this point where the capital Y value is 1. So I'm going to have a point here, pi over 2, comma 1. Okay. And I can observe that's actually going to be a high point on this graph. Nothing's going to go above that, because if I look over here, there's no point on the unit circle that's higher than that. Okay. All right, when my angle is pi, we've rotated to here. We're intersecting the unit circle at this point that has a capital Y value of 0. So we've got a point pi 0. I actually just label all of my points. So 0, 0, this would be pi 0. At 3 pi over 2, we've rotated down to here. We're intersecting the unit circle here, where the capital Y value is negative 1. And just like I could see that positive 1 was a high point, I can see that negative 1 is going to be a low point, because there's no point on the unit circle that's lower than that. Okay, at 2 pi, we have literally come full circle. We're back to this point where the Y value is 0. Okay, excellent. So I've marked off these 5 points that correspond to my quadrantal angles in one revolution. Now, of course, I could keep going, but if I keep going, I'm going to just be retracing the exact same path, and I'm going to see exactly the same pattern. So the graph, whatever it's doing from 0 to 2 pi, it's going to repeat that pattern over every interval of length 2 pi. Okay. So all the trig functions are what we call periodic. That means they have a pattern, they do their thing, and then they do it again. Okay. So they're going to just repeat this pattern. All right, so I want to basically connect the dots and then show that the pattern continues. If I looked here, I might be tempted to just connect the dots with straight lines. Now, hopefully you remember that the sine graph does not have any sharp corners in it. To see that, I might plot a few additional points, because there are some nice not quadrantal angles, some nice acute angles that I'm familiar with. So there's pi over 4, which is halfway in between pi 0 and pi over 2. And then there's pi over 6 and pi over 3, which would be 1/3 and 2/3 of the way through this little interval here. Okay, I know that at pi over 6, that corresponds to 30 degrees. At pi over 6, we're at a Y value of 1/2. So this point right here would be pi over 6 1/2. That right there is enough to tell me that I'm not connecting these points with a straight line, because horizontally I've traveled 1/3 of the distance, vertically I've traveled half of the distance. Okay. At pi over 4, sine of pi over 4 is root 2 over 2. Can be useful to know that root 2 is approximately 1.4. Of course, if you're estimating in homework, you've got a calculator available to you. But kind of nice to have that information, not absolutely necessary, but with that I can see that root 2 over 2 would be at about 0.7. Now, I'm going to label that as pi over 4 root 2 over 2. I estimated that as 0.7, but I'm going to label it exactly. Okay. And then at pi over 6, I know that sine is root 3 over 2. I'm sorry, at pi over 3. Pi over 6 was here. Pi over 3, sine of pi over 3 is root 3 over 2. Root 3 is about 1.7. So half of that would be about 0.85. And so that point right there is pi over 6, root 3 over 2. And that sort of suggests that as I play connect the dots, I want to have a nice, smooth, round curve. And it turns out that's exactly what we have. So we get this wave, and we actually call it a sine wave. Now, if I just graph that, I haven't graphed everything that we need to, because that suggests that it's only defined from 0 to 2 pi. it's actually defined everywhere. And I said it was just going to repeat its pattern, so I'm going to indicate that. And anytime you're graphing a sine or a cosine graph, I want to see arrows on the end. Okay, I want to see that the pattern continues. All right, so with this, we can now list a few properties of this function. So I can see the domain would just be all real numbers, everything from negative infinity to infinity. It's always defined. But the range is limited. It's going to be from -1 to 1. Now I include both of those points because I do have high points at 1 and low points at -1, but I can't go higher than 1 or lower than -1. Okay. Mentioned that this was a periodic function, and the period is just the length of the interval over which it will do its thing one time. That's just going to be 2 pi. And that corresponds to 1 revolution around the unit circle. You trace the unit circle once, calling out the capital Y values as you go. That gives you your pattern. Every new time you trace that circle, you're going to repeat that pattern. Okay. And then this graph also has something that we call an amplitude. Okay. There are a couple of ways to think of the amplitude. I can say it's essentially the height of one of these bumps, but I'm going to measure these bumps as the vertical distance from the high point to this middle point. I'm not looking at the vertical distance between a high and a low point, because I'm sort of thinking bump, bump, bump. So this bump here has a height of 1. So it's a vertical distance. Amplitude will always be positive. It's the vertical distance between the high point and the midpoint of the graph. Or equivalently, if I looked at the vertical distance between high and low, that would be 2. It's half of that. Okay. So I can think of this as either vertical distance between high point and midpoint, or half the vertical distance between high and low. Okay, so that is our lovely graph of sine. Okay. What I would like you to do before the next video is graph for me cosine. So you're going to be graphing y equals cosine of x. Okay. Now, it may be something that you're familiar with, which is great. It may be something that you've sort of forgotten. I would encourage you, though, to draw that unit circle that I had here a moment ago, and just, even if it's something that you have memorized, reinforce that the graph that you're getting is what you get. If you go around the unit circle, picking out for cosine of x, it would be the capital X values. So go ahead and graph that for me, and we'll do that together, go over that together at the beginning of the next video.